Okay, grade 8 students, it's your long weekend, Remembrance Day weekend. Hopefully all of you get to go to the credit union place for the ceremony for Remembrance Day on Monday. Take advantage of that. But on Tuesday, when you come back, you have to have your test corrections made. Make sure you use the sheet that I gave you for what I did wrong and what I should have done. On the side that it says what I did, please don't write just a sentence to explain what you did, but write verbatim what you actually wrote on your test. Highlight your errors so you understand what it was you did wrong. And then on the other side, watch this video to write down what you should have done to get the correct answer. So the first 5 questions are true and false, and it says the product of two proper fractions can be greater than 1. So if we take any proper fraction, a proper fraction is the opposite of an improper fraction. So a proper fraction are those fractions whose numerator is larger than the denominator, proper fractions. So if you take any two proper fractions, and I can take, let's just take a half multiplied by 3/4. If I think of what this says, this really says half of 3/4. And no matter what fraction this is, and no matter what fraction this is, it's always going to be a part of something less than 1. So when I multiply two fractions together and I have a part, something less than 1 of it, of something that's also less than 1, a part of a part will always be less than 1. So the answer is false. It can never be greater than 1 because a part of a part or a fraction of a fraction will always be less than the fraction. In this case, half of 3/4 is going to be less than 3/4. So therefore, it's going to end up being 3/8, which is less than 3/4. If I took 9/10 or 90% of, let's make it 99 over 100, a proper fraction. Well, 90% or 9/10 of this can't be bigger than the starting fraction, so it can't be bigger than a proper fraction, which means it has to be less than 1. That's a very difficult question to show why, but giving an example would be probably a step towards proving whether or not it's true and false. Question 2, half of 5/8 is greater than a quarter. So half of 5/8, half of 5/8. What I wanted you to do here was show me that half of 5/8 is really the multiplication of two fractions. And when I multiply that out, half of 5/8 is 5/16. Okay? Now 5/16 is the answer. Now 4/16 is 1/4. Right? 4/16 in lowest terms is 1/4. So therefore, 5/16 is more. And that's why we say the answer for this is true. Question three says the reciprocal of 2 1/4 is 8/9. So I actually made a mistake when I wrote this test, and I didn't realize it until afterwards. I meant to put 4/9, but I didn't. Or, sorry, 8/9. Yeah, 4/9, but I didn't, so I left it 8/9. Whatever, doesn't matter. It's an easy question anyway. The reciprocal of 2 1/4. So the first thing you have to do is say, well, 2 1/4 as an improper fraction is 9/4. Okay? The first thing you have to do is that. And the reciprocal of 9/4 would be taking that improper fraction and switching the numerator and the denominator of that particular fraction. So therefore, since 2 1/4 is 9/4, its reciprocal is 4/9, and therefore your answer is false. Question 4, 1 1/2 times 5/8 is greater than, remember, as Donnie will remind you, if the part that we say is being eaten by the greater than less than sign, we say is greater than. If it's pointing at it, it's less than. So 1 1/2 times 5/8 is greater than 1 1/2 plus 5/8. So the work I wanted you to show me here is I wanted you to physically multiply them together to get 15/16 for the answer for that first one. And over here, when you add them, you find a common denominator of 8. You would have, multiplied by 4, multiplied by 8, 12/8 plus 5/8, which is 17/8. 17/8, and 17/8 is, we'll just call it 2, not 1. My brain is gone. It's 2 and 1/8. So when you add them together, you get 2 and 1/8. Now, is 15/16 greater than 2 and 1/8? Obviously not, because 15/16 is less than 1, so it can't possibly be greater than 2 1/8, so therefore your answer is false. It's not greater. And finally, question number 5 in the true false is multiplying a fraction by its reciprocal will always be 0. The best way to do this is simply show an example. So 1/2 multiplied by its reciprocal. If I multiply this out, I'm going to get 2 over 2. And 2 over 2 does not mean 2, or 2 over 2 means 2 divided by 2, if you think of it as a division. And 2 divided by 2 is not 0, it's 1. So if we think of this as a fraction, if there's 2 parts and 2 are shaded in, I don't have nothing. I have 1 whole. So the answer is false. It always equals 1. Next question, question 6 says 3/4 multiplied by 5. Now, since you didn't have to actually show drawing or anything, what you wanted to do here was show that 5 as a whole number is really represented by 5 over 1. Multiply your numerators and multiply your denominators. Your answer should be 15/4. But you were told that you need to show all answers as mixed fractions in lowest terms. So how many 4s in 15? There's 3. And 3 left over for 3/4. Again, another way to do that is to use division. How many 4s in 15? There's 3. That's your whole number. 4 times 3 is 12. Subtract, you get remainder 3. The remainder is your numerator, and your denominator stays the same. Next question, 2 5/8 times 3. So when you multiply a mixed fraction by a whole number, there's 2 ways to do it. You could have technically multiplied the whole number by 3 and 5/8 by 3 to get the answer. Or alternatively, you could convert 2 5/8 to 21/8 multiplied by 3 over 1. That would give you 63 over 8. Again, watch this. If I go how many 63s, how many 8s in 63? There's 7 for 56. And that's remainder 7. Well, that's a coincidence again. So 7 is your whole number. That goes here. Your remainder goes up here. And your denominator stays the same. So your answer is 7 and 7/8. 3/8 divided by 2. Since 3/8 divided by 2 is the same thing as 3/8 divided by the fractions part of 2 is 2 over 1. You can keep the first fraction, change to multiplication, and use the reciprocal. When you multiply your numerators and you multiply your denominators, you end up with 3/16 as an answer. So the answer is, what is 3/8 divided in half? It's 3/16. Next question says 2 3/10 divided by 4. Again, the easiest way is to change your mixed fraction to an improper fraction, which would be 23/10. Remember, when you have that 2 3/10, it's 10 times 2 is 20, plus 3 is 23 over the original denominator. Okay, so 23/10 divided by 4 over 1 will become 23/10 multiplied by the reciprocal of 4, which is 1/4. Multiply your numerators, you get 23 times 1, which is 23, which equals 23. Multiply your denominators, which is 10 times 4. I'm having a hard time writing today, which is 40. Your answer is 23/40. Next question, you have a multiplication of 2 fractions. Now, there were a lot of people that just said 10 times 34 over 17 times 25 and got big numbers. 340 over 17 times 25, which is 17 times 25, which is 425. Now, the problem with this is I have to reduce this fraction down to lowest terms, and I have to first divide by 5. It's cumbersome. It's very difficult. But what you should have done is said that 34 over 17, using cross reduction. If I think about 34 over 17 as a fraction, both are divisible by the number 17, because 2 17s is 34. So that would reduce down to 2 over 1. And if I think about 10 over 25 as a fraction, both are divisible by 5, I would get 2 over 5. 2 over 5. And now, when I multiply it out, instead of multiplying 10 and 34 to get 340, and 17 and 25 to get 425, I'm actually going to multiply 2 by 2 and 1 by 5 to get your final answer of 4/5. Okay, so this was a tricky one for a lot of people. You needed to know cross reduction, and the lowest term answer is 4/5. Your next question is probably the easiest one of the test. 1/5 times 5/8. Most people got it because they either did this and got 5 over 40. They reduced it by 5 to get 1 over 8. There were a lot of other people who realized that cross reduction 5 over 5 still gave you the answer of 1 over 8 without having to reduce your final product. Your next question is a mixed product of two mixed fractions. So the first thing you're going to do is change both of your mixed fractions to improper. We're going to have 16 fifths multiplied by 5 quarters. Now, if you did not cross reduce, you ended up getting 16 times 5, which is 80, over 5 times 4, which is 20. And you say, well, both of those are divisible by 20. And you get 4 over 1, which is equal to 4. So your final answer would be 4. But if you cross reduced, 5 over 5 would become 1 over 1. 16 over 4 would become 4 over 1. And when you multiplied it out, you still would have got your final answer of 4 over 1, or just 4. 2/9 divided by 1/18 is the same thing as 2/9 multiplied by the reciprocal of 1/18, which is 18 over 1. If you didn't cross reduce, you went 2 times 18 over 9 times 1, which is 36 over 9, which is equal to 4. But if you did cross reduce, you went 18 over 9 is 2 over 1, which would have given you 4 over 1, which would have given you 4 as an answer as well. And your last question in this particular area is 1.5 divided by 2/3. First thing to do is don't use mixed fractions, use improper. Multiply that by the reciprocal of 2/3, which is 3 over 2. Multiply your numerators. 3 times 3 over 2 times 2. You get 9 over 4, which is 2 1/4. Your next question, 2 3/4 divided by 1 3/10. So we have mixed fractions here. As always, don't use operations with mixed fractions if you can. Always use them with improper. They're much easier. 2 3/4 would be 11 quarters. Remember, it's 4 times 2 is 8, plus 3 is 11 over 4. Divided by 1 times 10 is 10, plus 3 is 13. Now I'm going to keep the first fraction, change the multiplication by the reciprocal. When I multiply my numerators out, I get 110. When I multiply my denominators, I get 52. That will be 2, which is 104, and 6 over 52. I think I made a mistake somewhere here, but that's okay. I'll just do it out. Which is 2, and we both can be divided by 2. I just realized what I made a mistake of. Let's start this again. I made a mistake. The question, I wrote the question down wrong when I did the video, so it's 1 1/10, not 1 3/10. Let's try this again. So 2 3/4 is 11 quarters divided by 11 tenths, which when we change it to 11 quarters, keep your first fraction, multiplication by the reciprocal. There we go. That works better. When you cross reduce here, 11 over 11 will become 1 over 1. 10 over 4, if I think about 10 over 4, both are divisible by 2, giving me 5 over 2. 5 over 2, which your answer would be 5 over 2, which is equal to 2.5. If you didn't cross reduce, you got 110 over 44. Both are divisible by 2. You get 55 over 22, which is 2, and 11 over 22, which is 2.5. Your next question says 4/5 plus 1/2 times 3 3/10, excuse me. For this one, you need to follow BEDMAS. So the first thing you're going to do is write down your addition, because you're not going to do it yet. You're going to focus squarely on the multiplication of these two fractions. So what is 1/2 times 3/10? The answer is 3 over 20. So notice how 4/5 is still the first thing, even though you did 1/2 times 3/10. 4/5 plus is still your first term. Now you have addition of two fractions, which requires a common denominator. 3/20 will not change. But if you're having difficulty with making equivalent fraction, make sure you do what I'm doing right now. 5 times 4, it gives you that 20. And 4 times 4, since I multiplied the bottom by 4, is 16/20. Now that you have that, add your numerators, and keep your denominator for an answer of 19/20. Your next question, 2/3 take away 9/10 times a half. Same as the last question. You must make sure you do your multiplication first. So we have 2/3 take away whatever the product of this is, which will be 9/20. And now we have denominators of 3 and 20. And some people said to me during the test, I don't know what the common denominator is. But if you were to put 3 and 20 down and put all of the multiples of 3 and all the multiples of 20, the first one they're going to share, if you think about it logically, is 60. So therefore, your common denominator will be 60. And your equivalent fraction, 3 times 20 is 60, and therefore 2 times 20 is 40. 20 times 3 is 60, and 9 times 3 is 27. Now that we have common denominators, to subtract them, we simply subtract our numerators and keep our denominator, giving us an answer of 13/60. Our next question has 3 operations instead of 2. So we have brackets, and we have addition, and we have multiplication. The first thing I'm going to do is the brackets. Now the first multiple that 4 and 10 share, it's 4, 8, 12, 16, 20, and 10, and 20. 20 is the first one they share, so it's the lowest common denominator. If you used 40, that's fine. It just means your answer isn't in lowest terms. So we have 20 and 20. If you're having difficulty with equivalent fractions, make sure you put the times 5 there to give you 5/20, times 2 to give you 2/20, and 5/20 take away 2/20 is 3/20. So the only thing I simplified so far is the brackets. Now my next part is to do the multiplication. So I'm going to multiply them out. I'm not even going to change the cross reduction. I'm going to get 12 over 40. I'm not going to cross reduce. 3 times 4 is 12. 8 times 5 is 40. I'm going to multiply across here. Okay. Now we have addition of two fractions that don't have the same denominator. So I'm going to make the same denominator of 40. And this is going to be 6/40 plus 12/40, which is going to be 18/40, which is going to be 9/20 in lowest terms, because both 18 and 40 are divisible by 2. Your next question has 3 operations, but this time it's a little bit more complicated. It's all mixed fractions, whole numbers. So 2 3/5 times 5 plus, we're going to do the first thing we see, which is the multiplication. I'm going to do this, and actually in the same step, I'm going to do this multiplication as well. So I'm going to do it separately. I'm going to do multiplication both at the same time. This is going to be 13/5 times 5 over 1. And when I cross reduce this, the 5 over the 5 is going to become 1 over 1, which means the product of these two things is simply the whole number 13 plus 1/2 multiplied by 31/15. Okay, 31/15, which is going to be 31 over 30, or 1 and 1/30. Now, a lot of people, there weren't many people that got to this point and understood what to do next. You were locked into procedure, and you didn't stop to think about, what does this question say? 13 plus 1 and 1/30 is 14 and 1/30. It was so easy, but so many people made it more complicated than it need be. So your answer, your final answer, is 1 or 14 and 1/30. Your last two questions were your story problems. This is Aaron made $18 an hour and Billy makes 1 3/4 times as much per hour as Aaron. Carl makes 2.5 times as much as Billy. How much does each person make per hour? So set it up with an A, B, and C. Put Aaron as $18. Now Billy makes 1 3/4 times as much as Aaron. So $18 times 1 3/4 will be 18 as a whole number over 1, multiplied by 1 3/4 as a mixed fraction. If I cross reduce here, I get 9 over 2, which will give me 63 over 2, which is 31.5. Now, 31.5 or 31 and a half, I should put 31 and a half, is not money. You don't say 31 and a half dollars. You would say, therefore, he makes $31.50 because half a dollar is 50 cents. Now it says Carl makes 2.5 times as much as Billy. So if Billy makes $31.50 multiplied by 2.5, we really have the multiplication of two mixed fractions this time. So we're going to make this into 6263 over 2 multiplied by 5 over 2. That's going to be 315 over 4. And if I use my calculator, because I really need the decimal here, what is 315 divided by 4? It's 78.75. That's how much he makes an hour. Or as a fraction, if I wanted to think about this, it would be 78.75 dollars. So how much does each make? Well, Aaron makes 18, Billy makes 31.50, and Carl makes 78.50. What I love about this last question is how complex some people made it. So at a basketball game, 1,200 people were in attendance. 2/5 of the people are men, 1/8 of the people are women. The rest were children. What fraction of the people at the game were children? Now watch how easy this is. If I take the men plus the women, that will equal a particular fraction. But if I put plus children, that equals all of the people at the game. So if I say 2/5 plus 1/8, and I figure out what this is as a fraction. So I'm really just going to think about this as being the fraction of men and women. Find my common denominator, 40. Find my equivalent fractions of 16/40 and 5/40. So together, 21/40 will equal all of the people, or 100%. So 21/40 plus how many 40ths equals all of the people, 40/40. If you think of it this way, now it makes sense. What does that numerator have to be? It has to be 19/40, which means that 19/40 of is a fraction that represents all of the kids at the game.